guys to my YouTube channel. Today we are going to be looking at 15 likely questions for this week exam. Please, I want you to be attentive to the end of today's video lesson because these questions are very interesting questions. And not only will I just be answering the question, I'm also going to be throwing light in the area where the question was gotten from, so that if you see a question related to any of these, you will be able to demystify the problem. Okay, now first of all, our first question on the board says what? The compound specifically used to dry ammonia gas is what? The compound specifically used to dry ammonia gas is what? Remember that the answer to this question is quicklime. Quicklime. Quicklime has a chemical formula which is calcium oxide. That's the answer to this question. So take note of this, that quicklime, which is calcium oxide, is basically used to dry ammonia gas. So the answer to this question is quicklime. Take your pen and your book and jot that down. Remember that we have drying agent for gases. We have drying agent like H2SO4. But H2SO4 is not used to dry ammonia because the H2SO4 will react to the ammonia produced. The gas used to dry a compound must never react with the compound form. Otherwise, it will not be a suitable drying agent. Remember, the only compound that they use to dry all gases is called silica gel. Silica gel is used to dry all gases, but ammonia is specifically dried using quicklime or calcium oxide. Question number 2. Give 3 examples each of hygroscopic and deliquescent compound. Give me examples of hygroscopic and deliquescent compound. Why did I decide to do this? In the first day of Jamb, this particular question came out. In the second day of Jamb, they brought something similar to this. So if you know the examples of hygroscopic and the examples of deliquescent, you will be able to answer this question. Okay? Now, first of all, let's begin with the word hygroscopic. What are hygroscopic compounds? Hygroscopic. What are hygroscopic compounds? Hygroscopic compounds are those compounds that absorbs water from the atmosphere. Take your book and your pen. That absorbs water from the atmosphere and become moisty or sticky, but do not form solution. Yes, but do not form solution. So that is what we call hygroscopic compound. And examples of hygroscopic compound are number 1, copper 2 oxide is an example of hygroscopic compound. Calcium number 2, calcium oxide is an example of hygroscopic compound. Number 3, sodium triazonitrate 5 is an example of an hygroscopic compound. Okay, even your H2SO4, number 4, your H2SO4 is also another example of hygroscopic compound. Okay, now let's go to the next one, which is what? Deliquescent. Deliquescent are compound that absorbs what? Water from the atmosphere. They absorb so much water that at the end of the day, they turn into a what? A liquid. Remember, I said hygroscopic compound absorbs water, but they do not form solution. They don't turn into liquid. They only become moist and sticky. But deliquescent compound, they absorb water from the atmosphere and turn into solution. The deliquescent compound are more reactive than hygroscopic compound. Okay, so take note of this. I said copper 2 oxide, calcium oxide, sodium triazonitrate 5, and H2SO4 are example of deliquescent compound. So when you see example of which of these are not deliquescent or which of these are not hygroscopic, you should be able to give them reasonable example. Now let me give you examples of deliquescent compound. What are the examples of deliquescent compound? Please, can you give me examples of deliquescent compound? Number 1 example of deliquescent compound is your potassium hydroxide. Another example is your what? Sodium hydroxide. Your sodium hydroxide. Another example is your magnesium chloride. Another example is your calcium chloride. Another example is your iron 3 chloride. These are examples of deliquescent compound. Let me add one to this, phosphorus 5 oxide. They are all examples of deliquescent compound. Deliquescent compound absorbs water from the atmosphere and become musty or stinky. Not just that they absorb water, they are very reactive compound. Remember, if potassium hydroxide or sodium hydroxide is exposed to air, you will discover that it will absorb carbon dioxide and form sodium triisocarbonate 4, as well as all of these compounds. They are very reactive compound. Okay, so these are the example of hygroscopic, while this one are examples of what? Deliquescent. There's another nature of compound which we call the efflorescent compound. Efflorescent compound are compound. This one, they know they absorb water. No, what they do is that they lost their water of crystallization when they are exposed to the atmosphere. So for efflorescent compound, they give out water. They lost water of crystallization. Okay, they are usually called crystal salt or salt that contains water of crystallization. An example is your sodium triisocarbonate 4 decahydrate. Okay, you can still use sodium tetraisosulfate 6 decahydrate. Okay, any salt, most salt that contain water of crystallization, when you see that it contains H2O at the end of the compound, you know that they are fluorescent salt, most of them. So by the time this compound are exposed to the atmosphere, they loses their water of what? Crystallization. So that is what we have for you for hygroscopic, for deliquescent, and what? Fluorescent. So let's quickly go to the next question. The next question says, why is chlorine added into water during water purification? During the purification of water, remember that there's what we call disinfection. Just like I told you, I'm not just going to answer this question. No, I'm going to answer this question and then give you notes around this area so that when you see questions related to this, you'll be able to answer it. You might be very lucky to see direct question, okay? But if or eventually they give you question related to this, you will be able to answer it. Now, there's what we call the purification of water, and one of the steps involved in purifying water is called disinfection. Okay, now what are disinfectants? Disinfectants are substances added to water so that the water will become what? Totally clean from what? Causing infection. Okay, now if you add chlorine to the water during purification, it is known as chlorination. And why do we add chlorine in water purification? We add chlorine so as to kill the words, to kill the germs in the water. To kill germs in the water. Take note of that. That's the purpose of adding chlorine. Again, you can add what we call iodine. The process of adding iodine is called iodination. Why do we add iodine? To prevent goiter. Take note of that. To prevent goiter. Okay? Then also, we can also add fluorine. The process of adding fluorine to the water is known as fluorination. And when you add fluorine to the water, it helps to prevent what? Tooth decay. Please take note of that. Take note of that. Another important chemical compound that are added after disinfection is a compound called quicklime. You can add calcium hydroxide to water. What's the purpose of adding calcium hydroxide? The purpose of adding calcium hydroxide is to stabilize the pH of the water. Remember that these gases are acidic gases. So by the time these gases are added to the water becomes acidic. So in order for you to stabilize the pH of this water, you add your calcium hydroxide. By the time you do that, the pH of the water will now be equals to 7. Another reason for adding calcium hydroxide is to do what? Is to remove the temporary hardness of water from the water while purifying it. So please take note of this. All of these are known as what? Disinfection. Master the use of chlorine, use of iodine, use of fluorine, and use of calcium hydroxide. Next question. Permalloy is an alloy containing what? Permalloy is an alloy containing what? Let's clean this out of the board so we have space to answer that question. Remember, there's what we call allos. What are allos? Allos are mixtures of two or more word metals. When you combine two metals together, it forms what we call an alloy. Allos are not compound. Allos are what? They are mixtures. Take note of that. Allos are not compound. Allos are mixtures. And if allos are mixtures, what do they contain? They usually contain two or more word metals. Now, what are these metals? We have different types of allos and their constituents. Remember, we have the bronze. Bronze is an alloy containing copper and wood and tin. We have the brass. What is brass? Brass is an alloy containing copper and wood and zinc. We have what we call the coinage bronze. Coinage bronze. Coinage bronze is a mixture of your bronze and your brass. Just imagine you mix your bronze and your brass together. What will be the element that will be present? Copper will be there, tin will be there, and finally zinc will be there. Okay, we have what we call a steel. Steel or ordinary steel contains what? Contains your carbon and your what? Your iron. There's what we call stainless steel. There's what we call stainless steel. Please, I want you to take note of this. We have different types of steel. We have stainless steel, we have the ordinary steel, we have molybdenum steel, we have tungsten steel, but the most popular steel that we are aware of is the ordinary steel and the stainless steel. Okay, the stainless steel contains what? Iron, nickel, chromium, and some of this stainless steel contains what? Carbon in addition. Okay, so class, what about a nickel? What about a nickel? As the word implies, a nickel, aluminium, nickel, cobalt, iron. Whenever there's nickel, there must be iron. Take note of that. Whenever nickel is, iron must be what? Present. Okay? Take note of that, class. Again, what about when we talk about permalloy? Sorry, permalloy. The permalloy. Your permalloy consists of what? Nickel and what? And iron. That's permalloy. Okay? Permalloy consists of nickel and what now? Iron. Take note of that. So these are a few examples of what? We have another one called the soft soda. Soft soda comprises of lead and what? And tin. Okay? Soft soda comprises of lead and tin. Now, if you watch very well, you will see that there is a non-metal in one of these alloys. And the non-metal here is what? Your carbon. So we can simply say that steel is the only word, the only alloy that contains a non-metal as one of its word constituent. So the question here says permalloy is an alloy containing what? The answer is nickel and what? Iron. That is the two metal that makes up the word, the permalloy. Now let's quickly answer question number 5 before we go to other questions that we have for today. Now listen to me, class. There's a compound on the board called H3C attached to carbon, CH3. See a compound like this, class, OH. What is the name of this compound, class? What is the name of this compound? Now, remember one of the rules for counting organic compound or naming organic compound is to do what? Is to identify your longest continuous chain. That's the first thing to do when naming IUPAC compound. Identify the longest continuous chain. And if you identify the longest continuous chain, you will find out that the longest chain goes this way. Yes. So the longest chain, which is 1, 2, 3, comprises of 3 carbon. And don't forget, if a compound contains 3 carbon, we use the prefix prop. And if you contain single bond all through, we will now use the word propane. So let us end here, first of all, by saying propan, because we don't know what this will give us. Now, if you want to number the carbon atom, you number from the side close to the functional group, okay? So we start from here, 1, 2, 3. We find out that the OH is in the second carbon. Wow, that's interesting. Now, what's the name of this compound, class? The name of this compound is called Propan 2-O. Why did I say it's Propan 2-O? It is called Propan 2-O because the OH group is at the word second carbon. The OH group is at the word second carbon. Okay? The OH group is at the word second carbon. So that's what we call it Propan 2-O. Now let me give you another compound. If I have a compound like CH3, then something like this, CH3, then you have another CH3 here, and then you have OH. What's the name of this compound? Now, I'm going to give you just 1 minute to name this compound. 1 minute, please. I hope you have named this compound. Now, let's do it together. Now, like I told you, you count your longest continuous chain. If you count 1, 2, 3, it's the same with 1, 2, 3. So you can take your longest continuous chain from anywhere. So for having 3 carbon atoms, we use the word propan. Okay? So propan. Now remember, if you number 1, 2, 3, this guy is methyl. You write it down. Now where is the methyl found? Second carbon. So the compound is 2-methyl. Why did I put 2-methyl? It's to indicate that the methyl group is in the second carbon. 2-methyl, then this is your propan. The OH group is at the second carbon. So it will be called Propan 2-O. Now one more thing I need to show you is this. What type of alkanol is this? Now you can, first of all, if you check the alkyl group, you'll see that you have methyl here and methyl here. This alkanol contains 2 alkyl groups. Therefore, it is called secondary alkanol. But this alkanol contains 1, 2, 3. This one is what? Tertiary alkanol. Okay? Thank you very much. You can mark yourself. Now let's take other questions. Let's take the next phase of this question. The gas commonly used to demonstrate fountain experiment is what? By now, almost all of you should know it because I did it in my Jamb mock questions. The gas used to demonstrate fountain experiment. Remember that there are 2 basic gases that are used to demonstrate fountain experiment because they are very soluble in water. And the gases are ammonia and what? Hydrogen chloride. So the answer is ammonia and hydrogen chloride. Okay? So take note of that. These are the 2 gases used to demonstrate fountain experiment. Now in some conditions, you can use sulfur oxide too because it is also very soluble in water. But the 2 common compounds used to demonstrate fountain experiment is ammonia and hydrogen chloride. Write it down. Okay? Remember, if you put ammonia to water, it will form ammonium hydroxide. And ammonium hydroxide is a base. So if you add litmus paper to a solution containing ammonia, it will turn from red to blue. Take note of that. Then if you add litmus paper to a solution containing hydrogen chloride, to turn from blue to red. Why? Because this one is an acid, but this one is a what? A base. Take note of that. Next question. Give 4 examples of soluble and insoluble salt. Wow. 4 examples of soluble. I actually made this question this way because a question came out that they requested for which of these salts is a what? Soluble salt. Which of these salts is soluble? So that is why I give 4 examples of soluble and insoluble salt. Remember, a soluble salt is a salt that dissolves in water, while insoluble salt are those salts that does not dissolve in water. Now, how can you give us examples of soluble salt? Very, very easy. You must understand that there's what we call rules for solubility of salt. Rules for solubility of salt. So get your book and your pen and write this down. Rules for solubility of salt. So let me clean this part of the board so we can have a space to do that. Rules for solubility of salt. Okay? Rules for solubility of salt. What are the rules for solubility of salt? Rules for solubility of salt. Please take this down. Very, very important. Okay? Number one rule. All sodium, potassium, and ammonium salt are soluble in water. Okay? So all what? Potassium, sodium, and ammonium salt are soluble in water. Take note of that. Whether it's sodium chloride, sodium chloride, sodium sulfate, ammonium carbonate, all are soluble in water. Take note of that. Okay. Then rule number two. Take note. All chlorides